Hi everyone, thanks for tuning in. I'm excited to share with you another tutorial on Stable Diffusion tools that we have integrated into Grasshopper. I've done a similar exercise that takes in a parametric input such as this, like a facade template, and then transform it using artificial intelligence. So this is the output of Stable Diffusion. And we are able to control some of the features and behavior of this image by developing a parametric model. So in this tutorial, I'm going to first explain to you how this is set up. So I started with generating a simple division for a surface. So this is my input surface, which is a rectangle. And I have made some divisions that gives me this sort of tile distribution, and I place a point attractor to control the behavior of this facade. So I'm considering these as apertures or windows, and we can also control the number of cells for this division, so you can have as many units as possible. And the next phase is basically scaling them down using some attractor behavior. So this is these are the scaled down tiles, and you can also control how much aperture you want per the behavior. So if they're close to this attractor point, then you get smaller openings, and if they're further away, then you get larger openings. And I put together these two boundaries and define it as surfaces and give it a shade. In this case, I'm using black, but you can also input another color. So we can also use, for instance, a tone of red. And the next phase is basically I'm actually going to hide these, and I want to include that for my input. And by the way Stable Diffusion processes this information is through the colors of the pixels. So in your input, if you don't differentiate certain pixels, for instance, these white cells can kind of overlap with how the background is treated. So in this case, you might also want to generate another color for the windows. So since I have those tiles here, I'm going to go ahead and create another boundary surface and give it a different shade. So we can give it a tone of green and take off the boundary frames. So this will be these will be the tiles for the facade. And I've included a single black hatch at the base because I want to work on the facades. And in the second step, basically this is generated as an input for Stable Diffusion, but this sort of template parametric model, it could be varied. So you can actually control the number of cells, control the positioning of the attractor, and also control the behavior of the attraction, right? So you can also limit the frames, the openings of the facade. And once you have that, in the second step, you actually generate this as an input. Now, what I've done is I've actually defined the region. So in this case, my region is this frame here that will be input as a square image. And I defined here a directory. So I'm working on a facade project. So this would be input in a facade folder. And once I hit this button, the export drawing, what this custom tool does, it basically generates that as an input image. And this input image will now trigger the Stable Diffusion application or the algorithm. So all these pixel values, the distribution of these cells, they will generate or influence the output of the image. For this exercise, I'm going to use a custom trained Stable Diffusion model, which is CANNY. and we are working with a remote server that actually has this model. So the first thing I do is I switch to that model. So all the pipeline components are loaded into the GPU. And in the second phase, I define a prompt. So what I've done here is I want to generate a parametric facade with forest background. And you can input some negative prompts as well. So if you want to, for instance, take out some behavior of the facade or take out some features, you can write them in the negative prompt. And here we have the inference. So I want to run the Stable Diffusion in 100 cycles. The guidance and the strength basically control how much influence you want the prompt to have. So that's the guidance influence, and the strength comes from the image. So if I want the image to be to have some stronger influence on the output, I increase this threshold. And the next thing I do is I press run here, and that will send my request to the server. The server will generate the image, and my output is generated. So it's pretty interesting actually the way it interpreted the remaining pixels. Sometimes there might be some behavior that is triggered in these regions, and you get some sort of behavior like this, and you might want to update your prompt or the strength. But let's actually just say parametric facade, for instance. Let's simplify our prompt and run this again. And it basically gave me kind of a nighttime image with like lights. And you can start with this actually and play around with the kind of workflow that we generated here. So for instance, let's say I want to reduce the cell values, and I want to change the behavior of the attractor. And I can basically repeat these steps and update my input and press this button again, and what will happen is it will now use a different type of input, right? So I'm controlling the number of cell division as well as the behavior of the algorithm. And the nice thing about this one is you can basically store the history of the images that you generate. So I'm outputting 2 sets of images. So under the input, you can find the history of the inputs that you use, and the outputs will be stored in the output folder, so you can correlate them with the same seed value. And you can also keep track of your progression. So I'm going to do a few more exercises. So let's actually increase the horizontal count of the attractors, the panels, and I'm going to let's say make some reduction in the behavior. And here I'm going to write some materials. So for instance, concrete parametric facade panels with a forest background. Let's see what we get. And I'm going to update the input here. And this link is basically, I've chosen an existing file which reads this sort of input here, and this input could be updated with this component. So I'm exporting this the view frame inside this border, inside that folder, and that's updating this drawing, and that drawing is basically fed into Stable Diffusion, and I retrieve the result into the folder as well. So I'm going to press this now, and let's see what we get. So it ran its routine. Very interesting. So it's interpreted these as kind of the cells that we input, but it continued this region as a facade. So it has some sort of expression here too. So we could have also, extend the surface as well. So change the proportions, cover more region in the image as well. I'm going to press it again and generate another result. You can see it's kind of having a small effect here. One of the issues is the resolution per unit here, per facade panel is not too much. So it's kind of making an interpretation of what we want it to be. Let's actually go ahead and maybe add some more divisions and see what we get. So I'm going to make it in a 10 by 10 grid, play around with the positioning here. So I'm going to move this all the way to the top. Let's actually do it like this, and I'm going to increase it like that, and we can update it here and run it again. So very interesting. So it's because of the amount of green we have at the base, it kind of split the image into two regions. So this frame here is not registering as much influence as for the input image. So what we could do is actually reduce the frames at the base. So you can have this sort of feedback from the images that you get, update your parameters, and see if you can control the output a bit better. Well, now we got concrete panels, but it's kind of using kind of concrete on the sides as well. So I'm going to try a few more times and see if we can use some other features too. Now it's concrete took hold of the background, and these became kind of these units. So maybe we could do wooden this time and see wooden parametric facade, and negative prompt I'm going to write wall and see what we get. Well, now we get this sort of behavior, so we might want to try it a few more times to see, because every time you're getting a random result, so you might want to run it a few more times. And it's kind of placing these wooden elements, keeping the influence of the attractor base and placing it in a context. So it's trying to do a good job. And keep in mind, this is a flat image, right? So we are working on a facade, and this division here, the panel distribution, the geometry here could be anything we want it to be. We could also do another application for how to divide these panels. So I'm going to do another exercise where you can also have a bit more randomization in how to distribute these panels, so that you can generate different inputs. And let's see, I'm going to do one more time and play around with these units. So let's say we do something a bit more dense, and I'm also going to do something a bit let's actually adjust this region here too. So I'm going to draw a smaller region and place this at the base here and use this as my frame. So I'm increasing the resolution of the facade versus the background. So let's see what we get this time. So I'm going to update the image. Now this is occupying more pixels, and I'm going to run this one more time. Well, it's kind of interpreting it as kind of within a wooden frame. So maybe we kind of break that a bit. So I'm going to bake this, actually, the surface. And what I'm going to do is move this up, input it again. So now my surface is hovered, and I'm going to do maybe a region of green here too. So I'm going to hatch this and give it another color. So let's make it, let's choose it here, and let's see, we go here and I'm going to give it under a new layer. We can also define it as a custom hatch. But let's try to run it like this. I'm curious to see what we're going to get. So I'm keeping it as simple as possible. And let's update our input. Now that region is specified. So I'm going to do parametric facade with glass base. So it didn't update it. I'm going to run it again. Let's see if it's working. It's giving me some error. It might have to do with the seed value. Let's actually lock it to a seed. Let's see what the problem is. So I'm going to update this again. Run this again. There we go. So it's not doing a good job of interpreting this as the base. So it's giving me these glass panels, but this green area, it doesn't know how to interpret it because it's also broken from the existing facade. So let's see, I'm going to change it to another seed. Run it again. Well, now it's kind of exchanged it a bit more. So let's actually move this maybe here, and I'm going to extend it a bit more all the way here. So curious to see how this would turn up. Yeah, so it's trying to place something there, but it's not as clear. So I'm going to disconnect the seed so we will get more random iterations. There we go. So it's trying to place almost like a drawing. Maybe we take out wall. Parametric facade. Let's keep that. I'm having the simplest prompt. There we go. Very interesting. So it's it interpreted that green region as kind of a solid panel base. So this could be interesting to generate or try to do some stylistic elevation drawings and make them parametrically variable as well. And you can also control the regions here with some contrasting colors. So the Stable Diffusion algorithm will interpret them as a different material or different feature. And you can also keep track of all of these. So you will have a lot of facade variations, some artifacts emerging as well. But it will be interesting to test how to control the behavior using a parametric model. Like in this case, it's a simple parametric panelization. And see if you can enhance it with the kind of results you get from Stable Diffusion. So thanks for watching this tutorial. I will be uploading another video showing how to do a bit more dynamic division for the facades and surfaces. And we will also keep experimenting with other types of parametric scripts as well. So thanks for watching.